Okay, so we're going to continue our discussion of rational expressions. So in the first section, we introduced what a rational expression was, and we learned about reducing them and multiplying and dividing, and basically that whole section was just a matter of factoring. Then in the second section, we talked about adding and subtracting, and the main thing there was being able to find the common denominator. Okay, which sometimes involves factoring. And so just real quick, the common denominator is found by taking one of every factor. And if there are powers, you take the highest power. And then last time we were together in section 6.3, we used that same principle of the common denominator to simplify complex fractions. And what a complex fraction is little fractions inside of bigger fractions. So for the third section in a row, we are going to use the common denominator again, but this time to do something different. And so I'm starting off with a question that I asked the very first day of class before you even knew that you loved me so much. Okay, and it's this. What is the difference between these two mathematical objects right here? There's an equal sign for sure. And so what that means is this, okay? So you can look back in your notes. I've already mentioned this to you long ago. When you don't have an equal sign, this is called an expression. And all we can do with expressions is we can make them into new expressions. And so what we've been doing is we've been combining these fractions into new fractions. We did that when we multiplied, we did that when we divided, we did that when we added and subtracted. We took an expression and we made it into an equivalent and new looking expression. When you have the equal sign, you have an equation. And when we have an equation, we can solve. Whoops, I'm spelling that wrong. Oh, let's try again. We can solve. And what it means to solve is we come up with a value that creates a true statement. Okay, that creates equality. So for solving, we find a value or values that creates a true statement. We can't do that with an expression because there's no equal side. There's not two sides to anything right there. It's just an expression. So you can plug any value into an expression and you get your result. But I don't know what it would mean for it to be true or false because there's nothing to compare it to. An equal sign presents a comparison. Okay, that's the difference. And the reason I'm making a big deal of this, okay, so hopefully for you're looking at like, that's obvious, Perkster. I didn't even need to know that. The reason I'm making a big deal is probably the most common mistake on this test is not knowing what to do. It's not knowing when the proper time to do it is. Okay, and I will get students that will take expressions and try to solve them, which you can't because there's no comparison. There's no equality here. Okay, so just keep that in mind. So what we're going to do in this section is we're going to solve equations that have rational expressions in them. And it basically, in general, you know how to do this process because we did this on the first day of class, but we just did it with fractions that had numbers in the bottom, not variables. The process is going to be identical, absolutely no different. So let's look at example one. This is going to be my example, and then I've got several examples on this first page that are very similar. I want to take this equation that has fractions in it. I hate fractions. You hate fractions. We want to get rid of the fractions. I don't want to see them anymore. So what we're going to do is we are going to multiply every term by the LCD, the least common denominator. Okay, so we have found another use for the common denominator when I solve equations. Okay, so step number one in doing this is I'm going to go over to the side and I'm going to write down what is the common denominator. What's the LCD here? Okay, so tell me, remembering that every time we've done it in both other sections, we found common denominators. It is one of every factor. And if there's the power, it's the highest power. So what are the factors I need in this common denominator? Okay, an x and a 2. Those are the only two things I see. So I'm going to write I need a 2x. That's my common denominator. Is anyone seeing a different factor that I don't have there? Okay, please ask a question. I know this unit is difficult. Okay, I'm not belaboring, I'm not telling you it should be easy. So when you have questions, that's normal as part of learning. So be sure to ask them. Okay, so now what I'm going to do is I'm going to take that 2x, I'm going to multiply every fraction by 2x. So 2x, I'm going to write it over 1. I'm going to squeeze it in right here, 2x over 1, and then right here, 2x over 1. I'm multiplying every one of the terms by 2x over 1 because my goal is I want all those denominators to disappear. So let's go one fraction at a time. The first fraction, I've got 2 over x times 2x over 1. What happens there? The x's cancel. Heard somebody say. And then what's left over when those x's cancel? What does the first term become? Yep, 2 times 2 over 4. Minus the next fraction. I've got 3 over 2 times 2x over 1. What happens there? 2's cancel. And what's left over when those 2's cancel? What do we have? Negative 3x equals last fraction. I've got 7 over 2x times 2x over 1. What happens on that one? Everything cancels. It's a canceling party. Great. And what's left over after the canceling party? 7. There we go. And now what we're left with is an equation that we've been solving since the first day of class. Okay, so I'm hoping that this does not present any real obstacles to you. So I'm going to subtract 4 from both sides. So I've got negative 3x is equal to 7 minus 4 is 3. When we divide by negative 3, we get x is equal to negative 1. Before I call that my solution set, there is one other thing you have to remember. We did start with fractions, and this was the very first thing we talked about with rational expressions in the very first part of this unit. What can I never have in the denominator of one of my fractions? 0. So what you have to do is you just got to make sure, is negative 1 in the domain? Okay, is negative 1 something that doesn't make a denominator 0? And then in fact, on this front page, I don't think that's going to be a problem in any of the problems, but we're just going to get in that habit. So negative 1, when I put it in the first denominator, makes negative 1. That's fine. Negative 1, when I put it in the last denominator, 2 times negative 1 is negative 2. That's fine. So I do not get any zeros. So I'm golden. This is good. That is a good solution. When we flip over to the second page, there'll be some problems. When we check, we'll have to throw out some solutions and we'll go from there, but not on this problem. So far, so good. Before I have you do a problem, anybody got something that they don't understand or they don't see on that problem right there? All right, I'm trusting you because why would you come to class if you don't want to learn anything? So exercise 1 is basically the same sort of problem, just different numbers. So I'm going to give you a minute or two to go ahead and make some progress on exercise 1. Just to make sure everybody's working in the right direction here, what is the LCD that you are working with here? Okay, I'm going to go with the x. We need the x. But if I used 3x, 3x would not cancel out this 4x in the bottom. So what's my coefficient? What's the common multiple between 3 and 4? 12. So I need to use 12x right there. So if you said 3x or you said 4x, that's okay. Forgive yourself. And just remember that we need to make sure the coefficient, every denominator's coefficient divides into the common denominator. Okay, so if you missed that one, that's okay. The next exercise is going to present the same sort of situation. You're gonna get to redeem yourself. All right, so what I'm going to do is I'm going to take that 12x that we just talked about. So I'm going to I'm going to multiply each of these terms by 12x. I'm going to squeeze in a 12x right there, and then a 12x right here. Okay, so each of the terms get multiplied by 12x. By the way, it's that point in the problem. If you're multiplying by 3x here, 3 does not cancel with 4. Okay, that would be your roadblock to tell you, okay, I got to go back to the drawing board. Something's going wrong here, and come up with a new coefficient. So on the first term, I've got 12x times 1 over 3x. Notice the x's cancel, and 3 goes into 12 and leaves 4. And so 4 times 1 is 4. Minus the next one, 3 over 4x times 12x over 1. Again, the x's cancel, and 4 goes into 12 and leaves 3. So 3 times 3 is now 9. And on the other side of the equation, 3 goes into 12 and leaves 4. The x's don't cancel because there's no x in the denominator there. So I have 1 times 4x or 4x. That's what I get when everything cancels out. So this equation is slightly quicker to solve than the previous one. I don't have to move any sides. 4 minus 9 is -5. Divide both sides by 4. And I get x is equal to -5/4. Once again, you check to make sure that that doesn't make any denominator 0. And it doesn't, because the only number that would make any of my denominators 0 is the value 0. So that is a great solution. So I'm going to put it in a solution set and be happy about it. All right, so one way or another, you learned something on that problem. Okay, so remember, if you make a mistake, it's okay. Don't beat yourself up. There's no shame in making mistakes. There are opportunities to learn. So now take what you've learned and try exercise 2. Very similar problem. That's why I put more than one example on all these problems, is so that you can work out and sort through any misconceptions. Once again, just to make sure we're all on the same page here, what is the least common denominator of these fractions right here that we're going to work on? Okay, again, if you said 4x, That's not quite enough because if I put a 4x right here, 4 is not going to cancel with the 20. So we need to make sure that whatever here is it's the least common multiple. And again, the least common multiple can be found by the listing method. You can list out the multiples of 4 and the multiples of 20, and you can circle the first one. So the common denominator here is going to be 20x. That's what I have to multiply by. A little rule of thumb for you, if you're struggling with that, is every denominator should divide evenly into what your common denominator is. Okay? You should have no denominators left. All right, so I'm multiplying each term here by 20x. So in the first fraction, the 20s cancel, and I have x times -3, bless you, or -3x, plus the next one, I've got 2 over x times 20x. The x's cancel, and I have 2 times 20, or 40, equals. Then on the other side, I've got 5 over 4x times 20x. The x's cancel, and then 4 goes into 25 times. So 5 times 5 is 25. There's my reduced things. I've got no more denominators, no more fractions to worry about. So all I have to do is solve this equation by first subtracting 40. And then 25 minus 40 is -15. Divide by -3. And I get x is 5. 5 does not make any of my denominators 0. Again, the only thing that would make any of these denominators 0 is the value 0. So I don't have to worry. That is a fine solution. It's in the domain of all of my fractions. All right, we're going to turn our attention to exercise 3. I'm going to give you one little bit of advice. What you're going to notice is when you clear the fractions, you are not going to have a linear equation. It's going to be a quadratic equation that you're going to have to factor and solve. Okay, like we did in the last chapter. What's the common denominator on this one right here? Just p. P is the only denominator. So p. The 8 is not a denominator, so you do not need to include it. The 15 is not a denominator. The only denominator is the p. So right there, the LCD is p. right, so I'm going to multiply each of my terms by p. So the first one, p times p is p squared. There's my quadratic. Plus 15 over p times p over 1. Here the p's cancel, and I have 15. And then on the other side, negative 8 times p is negative 8p. So if you did that, you did 100% great job. You've done the new bit. That's all that's new in this section is clearing the fractions. Now it's an equation that I've seen before. Since it's quadratic, remind me, because it's been a while, what is the first step I have to do here in order to solve this quadratic equation? Yeah, you got to set it equal to 0. I got to move the 8p over. So I will do that as I was told to do. So perfect. And so what I have is p squared plus 8p plus 15 equals 0. P squared is p times p. I got to unfoil this now. And what are the two factors of 15 that are going to add up to 8? Perfect. 3 and 5. And now by the principle of zero products, I take each of those factors. I don't know what they are, but I know that one of them has to be 0. So I say, okay, p plus 3 equals 0 or p plus 5 equals 0. In the first case, p is negative 3. In the second case, p is negative 5. Again, neither of those make my denominator 0. The only thing that makes this denominator 0 is the value 0. So both of those are legit solutions. So here's my solution set. I've got 2 answers this time that make a true statement in that equation. All right, whatever questions you have, please bring them up. Go to exercise 4. We got 2 more examples of just having monomial denominators. And then we're going to flip the page and we're going to talk about what happens when I have binomials. Same process. What common denominator did you come up with for this problem? Okay, yes. The common multiple between 3 and 5 and 45 is 45, and then we need the x. Okay, so continue working the problem with that common denominator. All right, I've got my 45x here that you told me was the common denominator. So here we go. The first fraction has a 3x in the denominator. So we see that the x's cancel. That's good news. How many times does 3 go into 45? 15, for sure. So I've got 15 times 2, that is 30 as my first term, equals the next one. Again, the x's cancel. How many times does 5 go into 45? 9. So I have 9 times 6. 9 times 6 is 54 plus. And last but not least, the 45s cancel here, and I'm just left with 8 times x. So 8x. Perfect. Now I've just got a linear equation, no quadratics on this one. So I'm going to subtract the 54. And I have negative 24 is equal to 8x, and divide by 8. And I get x is negative 3. Once again, the only number that I would have to throw away would be 0, because 3 times 0 is 0, 5 times 0 is 0. That's not this. So there's my solution set, negative 3. All right, last one. We've got one more with monomials in the denominator. Exercise 5, please. What's the LCD on this problem right here that you're using? Yep, 4x. Indeed, that's true. So keep working. All right, so on this one, the first term, the 4's cancel, and I have x times x, or x squared, minus the next one, both the 4's and the x's cancel, and I just have 21. And on the right side of this, I have negative 1 times 4x, that's negative 4x. So for the second problem, I have a quadratic. That's okay. We can press on through this. I add the 4x just like we did on the other one. We had to get the 8p on the other side. So I have x squared plus 4x minus 21 equals 0. I'm unfoiling it now. What are the two factors of negative 21 that are going to add up to positive 4? Plus 7 and minus 3. That's fantastic. I'm going to now apply the principle of zero products. I'm going to take each of those factors. I'm going to set them equal to 0. So I've got the x plus 7 equals 0, the x minus 3 equals 0. And in this case, my first solution is negative 7. This case, the second one's 3. Once again, neither of those make a denominator 0. And here is my solution set, negative 7 and 3. All right, before I flip the page, are there any questions on what to do when you have monomials in the denominator? You're going to have a bunch of homework problems like that. There'll be a couple on the test just like that. Okay, now what we're going to do is we're going to flip over to the back page. And now we've got the situation where my denominators are not monomials. And I told you this when we first started adding and subtracting. I actually think this is a slightly easier situation to find your common denominators. I don't think there's as much busy work. I don't know if you agree with me or not, but you don't have to agree with me. That's the beauty of life. Okay, so here we go. We're going to go ahead and clear these fractions. What I need to do is figure out the least common denominator. And in order to do that, I need to make sure all my denominators are factored. So x minus 3, that's factored. X plus 3, that's factored. X squared minus 9, there's the 1. So that's a difference of squares. You'll notice on this page, most of the factoring is nice and straightforward because that's not what I'm concerned about today. So difference of squares, x squared minus 9 is going to be plus 3 minus 3. So what is my least common denominator? What factors do I need in the least common denominator? One of every factor you see, and if there's powers, you take the highest power. And so the factors that I see, just as I was told, x plus 3, x minus 3, for sure. Excellent. So what I'm going to do is I'm going to take x plus 3, x minus 3. I'm going to write it once near each fraction. I'm going to have to do a little squeezing here. Sorry about this. X plus 3, x minus 3. And then on the other side, I've got x plus 3, x minus 3. Just like we were doing before, the process is absolutely no different than what we were doing on the front page. Now I just have some binomials. And the biggest challenge with binomials is just making sure you distribute. Okay, so go slow, make sure you account for all your terms so that your arithmetic works out nice. So the first fraction, what cancels here when I multiply by the common denominator? Yep, the x minus 3 is right there, staring us in the face. So now I have 2 times x plus 3. What do I get when I do 2 times x plus 3? 2x plus 6. Yes, don't be shy. You got that. It was great. The next fraction, the x plus 3's cancel. And now I've got, don't forget this negative, this minus sign. I've got negative 3 times x minus 3. So that's going to be negative 3x plus 9. And then on the other side of the equation, what cancels over there? Everything does. Woohoo! And I'm just left with 12. Oh, good. I got a linear equation. That's fantastic news. Let's go. 2x minus 3x is negative x. 6 plus 9 is 15. Let's subtract that 15 from both sides because we've got to get the x on one side, the number on the other. That's our usual way to solve a linear equation. 12 minus 15 is negative 3. And when I divide by negative 1, I get x equals 3. Okay, now before I get all excited and throw that in a solution set and move on to the next problem, for the first time since I mentioned it, when I go to check this 3, what happens when I plug 3 into this first denominator right here? You get 0. 3 minus 3 is 0. So that's not in the domain. Oh no, all that work and I'm throwing that answer out. So there's no answer, there's no solution to this. So I'm going to write empty set. The only possible solution I got, I have to throw out because it's not in the domain. So that means there is no solution to the problem. Now, sometimes that'll happen on these, but not all the time. You might do one of these problems that you end up with 2 solutions and you might throw one out and keep one or throw them both out or keep them both. Just, you always got to check. Any questions about that? Anything that seems a little sketchy right there? All right, then do exercise 6. It's essentially the same problem, just different numbers. I don't know how this one works out, if it's no solution or not. So we're going to live in the mystery. while you're working, keep working. I'm just going to work out the common denominator for anyone struggling with that part right there. Right, so the first thing I did was I factored the denominator that needed it, which was this last one, t squared minus 49. And I got the factors t plus 7, t minus 7. And so the common denominator is one of every factor you see. And then if there's powers, the highest power. So the factors that I see are the t minus 7, the t plus 7. Pretty straightforward. All these problems are going to be pretty straightforward. So now I multiply each of the three fractions by t plus 7, t minus 7. And we notice in the first one, the t minus 7s cancel. And I have 1 times t plus 7, which is just t plus 7. So we'll write that there. The next sign is a plus. The next one, the t plus 7s cancel. So I have 2 times t plus 7. That becomes 2t minus 14. And then on the other side of this, both cancel, the t plus 7 and the t minus 7, and I'm left with 14. I'm going to pause right here. Does anyone have a question about where I got any of those terms right there? If you can do both these first problems, the next 4 are not going to present you any new challenges. They're all the same. It's just practice. So if you got a question, ask it so you can work it out for the next ones. So combine my like terms. T plus 2t is 3 of them. 7 minus 14 is negative 7. Add the 7 to both sides, and I get the 3t equals 21. I'm hoping that this is child's play for you, solving these linear equations. And then t is 7. Now, once again, just because it's a concept I wanted to reinforce, we noticed that that is you did great if you got t equals 7. But what happens here? Yeah, the 7, if I put it right here, 7 minus 7 is 0. So sorry, I have to throw that answer out. And once again, we have the solution set of the empty set. There is no solution to the rational equation. All right, I promised you that that's not going to happen all the time. I'm pretty sure that that does not happen on exercise 7. So go ahead and give exercise 7 a try. So I factored the middle denominator, got x plus 2x minus 2, gave me a common denominator of x plus 2 minus 2. So I'm going to write that in right now. Keep working. I know that you're probably still working there. So just letting you know what I'm doing. All right, so when I multiply every one of my fractions by x plus 2, x minus 2, here's how it goes. The first fraction, the x minus 2's cancel, and I have 3 times x plus 2, so hopefully you wrote down 3x plus 6. Don't forget to distribute. Plus, and then the next one, both cancel, the x plus 2's and the x minus 2's, so I'm just left with 21 from that fraction. And on the other side, x plus 2's cancel, and when I go ahead and distribute, I've got 14x and then minus 28. Everyone tracking where these numbers are coming from? All right, well, I hope you're feeling as good as I am today. So 6 plus 21 is 27. Okay, so I'm going to subtract the 14x from both sides. And when I do that, 3x minus 14 is negative 11x. I'm going to subtract the 27 from both sides. And when I do that, negative 28 and negative 27 is negative 55. Divide by the negative 11, and I get x is 5. Does x equal to 5 make any of my denominators 0? No, it does not. That is a great solution. Congratulations. So I'm going to use it right there. So it doesn't happen every problem. I just did it on 2 consecutive just so that you would you recognize it. All right, exercise 8. Keep going. A little more factoring on exercise 8 just to increase the fun level. I'm just going to get started factoring, so keep working. You can check your LCD with mine when you get there. just to give you a nudge, I know you're not done, so I'm just going to get everybody caught up on the common denominator. The first denominator factors to x minus 4x plus 2. Those are the two factors of -8 that add up to -2. The next denominator factors to x plus 4x plus 2. Those are the factors of +8 that add up to +6. Then the last one's a difference of squares. We've got x plus 4, x minus 4. So when I go to declare the LCD, you need one of every factor you see. And if there's power, it's the highest power. And so one of every factor I see is I see an x minus 4, I see an x plus 4, I see an x plus 2. So you need 3 factors in your common denominator. So I know it's pretty squished, and I'm sorry about that, but I like to write the common denominator for each fraction so I can cross things out. So I've written the 3 factors, x minus 4, x plus 4, x plus 2, x minus 4, x plus 4, x minus 2, and one more time, x minus 4 plus 4 minus 2. Okay, so I'm going to give you another 60 seconds or so to make any more progress that you need to with the rest of this and come close to an answer, and then we'll see how does this work out at the end. So the first fraction, the minus 4s cancel, the plus 2s cancel. So you have 2 times x plus 4. So that's 2x plus 8. The middle one, don't forget this negative. That's sometimes a detail in the midst of all the other chaos that we overlook. So we've got x plus 4. We've got x plus 2. So I have -4 times whoops, I canceled out the wrong one. I like to cross it out and I crossed out the wrong one. So it's the -4 right here, even more of a mess. -4 times x minus 4, that gives me -4x and then plus 16 equals, and on the other side, I've got x plus 4s, I've got x minus 4s. So I have 2 times x minus 2, that's 2x minus 4 is what I'm left with. So I'll combine my like terms, 2x minus 4x, -2 of them, 8 and 16, that's 24, is equal to 2x minus 4. I'm going to get all my x's on one side. Yes, sir.
X plus 2.
X, yes. Thank you. I guess I'm a little distracted today. Sorry. Okay, so that should be plus. All right, so the thing that was pointed out to me is I wrote a minus there for some crazy reason. That should have been a plus because that's what the common denominator was. So I messed up the sign as I was telling you not to mess up the signs. So learn from my mistakes, okay, is what I'm trying to do here. Teaching you what not to do. And I think I'm doing it very effectively as well. All right, so now that I'm here, thank you for checking me. Everybody else better check me. I'm going to get all the x's on one side, all the numbers on the other side, and hopefully I can do this without any more incidents. -2x, -2x is -4x. I'm going to subtract the 24. 4 minus 24 is -20. And then finally, I divide by -4. And once again, I get the x value 5. And does 5 make any of my denominators 0? No, it doesn't. So there we go. 5 is a great solution. Okay, 2 more problems. We are rolling to the finish line of this section. So do the next one, exercise 9. I'll check in with you on the least common denominator because sometimes students make assumptions on this one that they shouldn't. Remember, common denominator is one of every factor you see. All right, what'd you write down as the common denominator on this one? Nothing needs to be factored. Yeah, don't forget that this x and x minus 2, those are separate factors. I know the x minus 2 has an x, but remember, because there's the -2, those things are glued together now. So it's x and x minus 2. Both of those things are necessary as the common denominator. I'm going to multiply everything by x and x minus 2. So in the first fraction, the x minus 2's go away. And I have x times 2x, so 2x squared. I've got a quadratic here, so we'll take care of that in a little while. On the other side, the x's cancel, and I have 3 times x minus 2, so that's 3x minus 6. And then plus, and then the x minus 2's cancel, and I have 4 times x, or 4x. Yes, it would. Boy, the Perkster is doing great today. So I should give you an automatic A, but I won't, but I should. Okay, so anyway, yes, there's a negative there, right in front of me. No excuses. Anyway, so here we go. I've got 2x squared. Negative 3x plus 4x is 1x minus 6. And I'm recording this today too. That's okay. I don't mind my mistakes being out there. I'm gonna have you do the next problem. So that's all I have to say. So there we go. I'm glad somebody's awake here. So negative 3 times x is negative 3x, and then negative 3 times negative 2 is plus 6. Yes, if you've got to have all those details, great. So then negative 3x plus 4x is still x, and then I've got a plus 6. Anything else you want to point out to me that I've done wrong? Yeah, I know. I'm bald. You got that. I got all sorts of flaws. Okay. Now I'm going to put everything on the same side because it is a quadratic. So I'm going to subtract the x. I'm going to subtract the 6. And what I have is 2x squared minus x minus 6 equals 0. So just because I want to make sure we don't lose this ability that we either learned or we remembered back in the factoring chapter, just wanted to make sure, since we have a little time, to have a quadratic where I have a number in front of the x squared. So I'm going to, if you have another way, remember I've said this all along, you're not obligated to do this by the AC method, but that's how I'm going to do it. And so I'm going to take the 2 times the negative 6, and I get negative 12. And now I need the 2 factors of negative 12 that are going to add up to negative 1, and that's going to be negative 4 and positive 3. I'm going to use those 2 factors as new coefficients to split this middle term into 2 terms. So I have 2x squared, and then minus 4x, and then plus 3x, then minus 6, and it's equal to 0. And if you recall from when we talked about this, if you have done this already and you put the positive 3x first and the minus 4x second, it doesn't matter. You will get the same 2 factors as me. I'm now going to do this by grouping. And I'm going to take a 2x out of the first 2. 2x squared divided by 2x leaves x. Negative 4x divided by 2 leaves negative 2. And then I can take a 3 out of the next 2 terms. 3x, factor out the 3, leaves x. Negative 6, factor out the 3 is negative 2. The grouping worked. I've got the same thing in parentheses. Okay, we saw this all along. So I'm going to factor that x minus 2 out. And then what's left from the first term is the 2x. from the second term, the plus 3. And that equals 0. And finally, at long last, after all this work, I'm ready to be done with the problem. My two factors, I've got x minus 2 equals 0. And then I've got 2x plus 3 equals 0. I'm going to skip over my footer here. If x minus 2 equals 0, then the first possible solution is 2. And then if 2x plus 3 is 0, when I subtract the 3 and divide by 2, I get negative 3/2. All right, when I'm looking at both of those answers and I look back up at my problem, what do I need to do? Make sure that none of my denominators are 0. So how about the x equals 2? Is x equal 2 legit? No, it's not, because x equal to 2 makes this denominator right here 0. 2 minus 2 will be 0. So I throw that one out. Goodbye. Don't need you. And then the x is negative 3/2 or negative 1.5. Does negative 1.5 make any of these denominators 0? No, so that's a keeper. Okay, so that's my solution set. So on this particular problem, I keep one, I throw the other one out. So my solution set is negative 3/2. All right, last problem for the day. If I can make it through without sign errors, we're going to do my best. Exercise 10, go for it. Just to give you a little nudge, I did my factoring. The first one, the two factors of negative 6 that add up to plus 1 are y plus 3, y minus 2. The next one, the two factors of negative 2 that add up to negative 1 are y minus 2, y plus 1. And then the last one, the two factors of 3 that add up to 4 are y plus 3, y plus 1. Least common denominator is 1 of every factor you see. So I see a y plus 3, I see a y minus 2, and a y plus 1. There's my LCD. So I'm going to now write that by every fraction. You keep working, and we'll compare notes in just a minute. All right, so here goes. Correct me when I'm wrong, because it'll probably happen. So we're going to get rid of the first one of the y plus 3s and the y minus 2s. And then I have 2 times y plus 1, so that's 2y plus 2. Plus, and then the next one, the y minus 2s cancel and the y plus 1s. So I have 1 times y plus 3, which is just y plus 3. On the other side, the y plus 3s cancel, the y plus 1s cancel, and I have 4 times y minus 2, so that's 4y minus 8. So far, I've managed to do this without any devastating impact. So I'm doing okay. Are you doing okay, though? I'm sorry for my mistakes and carelessness. I hope it's not confounding you any more than it needs to. All right, so this is just a linear equation. The rest of this is downhill. So 2y and y is 3y plus 5 is equal to 4y minus 8. I'm going to bring all my y's to the left, all my other numbers to the right, because that's what I like to do. You can do otherwise if you like. 3y minus 4y is negative y. Going to subtract the 5. Negative 8 and negative 5 is negative 13. And divide by negative 1, and I get y is 13. That does not make any of my factors 0. The only thing I would have to look out for is a negative 3 or a 2 or a negative 1. That's not what I have. There is my solution set right there. The solution set with 13 in it.